All right, so we're going to look at the idea of even and odd functions. So an even function is any function where if I take a function and replace x with negative x, I will get the original function f of x. An odd function is where I'm going to take an f of negative x. I'm going to replace all the x's with negative x, and I'm going to get the opposite function. So the first example that was given, you said the f of x equals negative 4x to the third. So in this case, this is my original function, f of negative x. Now one thing I like to do is I like to figure out what would the opposite function be. Now the opposite function for us is going to be if I change all the signs in all the terms. Now in this case there's only one term, so I would just change that from a negative to a positive. So when I figure out what f of negative x is, when I replace x with negative x, if I get this, the original, we'd say it's even. If I plug it in and get this, then I would say it's odd. If I get something that's totally different, then we would say it's neither even or odd. You can have stuff that's neither, or is not even or odd. So now if I replace it in this function, I'm going to replace negative x with negative x. So I will get negative 4 times negative x to the third power. So when I plug this in, I get negative 4. Now if I take negative x to the third power, that's negative x times negative x times negative x. You don't have to write this out, but just to show you that there are 4 negative signs. And if there are 4 negative signs, that's going to make it a positive 4x to the third. Now if we look at this, now 4x to the third is not the same as the original. Okay? It is not negative 4x cubed. So it's not even. Because the original, remember, was negative 4x cubed. And we are missing a negative sign. Now in this case, if you look at the odd one, it is exactly the odd. So it is the opposite of our original function. So this equals the opposite of the original function. Because we said the opposite of the original function was this. So this is an odd function. Let's look at another example. So let's say I have f of x equal to x squared plus x. Now, that's the original function. If I was going to take the opposite function, then I just change all the signs. So it becomes negative x squared and negative x. And so now I want to figure out if I replace x with negative x, so everywhere in the function, if I replace x with negative x, I want to see, do I turn out with the original or the opposite or neither? So if I replace x with negative x, in this first one, in the original, I get this. And so now we'll simplify and see what we get. Now negative x squared is negative x times negative x. Now that's 2 negative signs, because this is going to be negative x times negative x plus negative x. Well, negative x times negative x is going to be x squared. You don't have to write the prior step, but I think it really shows that there are an even number of negative signs for that one. And then we have plus x plus negative x, which is just minus x. Now, if we look what we get when we replace negative x with negative x, this is not the original function. It's not what we started with. But it's also not the opposite function, because the opposite function, they both have to change signs. They both would have to become negative. So in this case, this is neither even or odd. And there are functions that are neither. So, first one odd, second one neither. We could look at a one that might be even. So an even one might, here is an even function, just to show you. So we have x squared plus 5. So if I replace x with negative x, we get negative x squared plus 5. Now, negative x times negative x, again, like we said before, negative x times negative x is going to be positive x squared. And then the 5 just stays the same. So now, f of negative x, when I plugged in the negative x, I got right back where I started, which is the original function. And so if I get back to the original function, we say this is an even function.